Hello, guys. Can you hear me well? Fine. I am Ivan Topolnjak. I'm one of the core developers of Kamon. Are any Kamon users around here? Yeah? Thanks for using our tool. For those of you who don't know what Kamon is an open source project aimed to monitoring applications made with Akka, Spray, and Play. And it's meant to be used in production. It's not just a toy thing that you use while you're developing. It's something for using on production. It has been in under development for over a year now. We're type-safe technology partner since May this year, so there is collaboration to make this even better. And it's already being used in production for some of our users, so that's something that you can rely on. The motivations for doing this is that when we started doing some really cool stuff with Spray and Akka, we got to the point where we had some apps that we wanted to take into production, but we couldn't do that without having proper monitoring. And there was nothing available that we could use. The only thing that was available at the time was the type-safe console, and it wasn't like the best thing to use at the moment. And also, we could not use that then. So we saw what people was doing at the time. Some guys were wrapping every single message in their Akka applications or their features, or doing some sort of metric collection stuff, and everyone was doing something different. Very similar things, but everything was different. And we decided to do something that could be shared with other people, that works well, and like try to solve these problems once and do it for everyone. So why do production monitoring? It's very surprising to us that many people have applications in production, but they don't monitor that. And there is a sad thing that is, there is a gap between what you think about what your application does, the way it does that in production, and the way it does that in development. It's always different. And you need to know how your application is going on when your users are using it. I mean, you want happy users. You don't want users waiting for your page to load. So there is a talk made by Kodahel where he explains very well why you should do production monitoring, and I highly encourage you guys to go and click that link and see that talk so you know what I'm talking about. Next, I'm going to talk about the two biggest challenges we had when developing this tool. And the first one is keeping context across the events. So if you look at a traditional application, like the old guys doing Java stuff, where everything is blocking, and there is a thread that is always attached to the execution of a very specific request. So if you do some JDBC calls, or you do HTTP requests, or you have some business logic to do, everything happens sequentially in the same thread. So it's easy to keep context there, because you can put something on a thread local, and you can access it everywhere when you're doing the application. So some people move a little bit beyond that and started submitting things to thread pools, so you can have some sort of parallelism while working on a request. But usually you do that, but you still have one thread that is attached to the transaction. And when those things complete and come back here, then you keep doing something sequentially. So if you have a thread local and maybe some other tools, you can still keep context around the things. But when you work with reactive applications, when you are working with Akka, with Spray, with Play, it's not the same thing. There is no longer a single thread attached to a transaction, and everything just flows through the actors or futures or the sync callbacks and futures, and you need a way to keep a context across all those things. So what we did was we created something we call a trace context, and that thing has a name, has a token, and has some other things that we use for gathering metrics around that. And we propagate that through all the asynchronous events on the system. So if there is a trace context available when you send a message to an actor, that message goes with that trace context. So when the receiver processes that message, that same trace context will be available then. So if that generates more events, then the trace context is going to be propagated across all events. So we do that with regular tail, when you ask, when you use pipe. Also when the actor fails and the child fails, and it sends a supervision message to the parent, and that also carries the trace context. And also we do that with future. So when the body of a future executes, the trace context that was available when the feature was created is also available when that executes. And if you transform the future into other stuff, then all those callbacks will also have the same trace context available. So basically, every event that goes from the moment you started a trace to the moment it finishes will have the same trace context available. So we have a very simple API for that. You basically grab a part of your code with this with new trace context thing, and it creates a new one, and it gets propagated all the way down to the moment you do a trace recorded that finish. So the next challenge is, well, now we have context. We know when something starts and when something ends, and now we want to measure, no? And when I mean measure and measure everything, I don't mean like having too many things being counted. When you count the right things, you need to know all the values about that very specific thing. If you're measuring latency, if you're doing sampling for that, and you're like sampling 1 out of each 10 requests, and you measure that, basically you're throwing away 90% of your data. And that can be a lot of people that is falling in that 90% that is not happy about the service you're giving them. So you need to know about everything. So if you're measuring latency for this specific request, you need to know all the latency measurements for that specific request. And also, you take statistics about that. So you need numbers that tell you things. And we don't know what is important for you. Maybe you like the mean, the median, the maximum. It's obviously not a good way to go about measuring stuff, but we don't know what you want to do. So how do we solve that? Well, we keep all the data, all the measurements we take from your application, we're keeping them, and you decide what to do with your information. So it's kind of easy. We just need to be able to store millions of measurements per second, which can happen in many busy applications. We need to have a limited and predictable memory footprint for doing that, and also do it with a very low overhead. It's pretty easy stuff, I guess. No, it is not. And you're asking yourself, is it even possible to do that? And yes, it is. There's a thing called the High Dynamic Range histogram. It has been created by Gil Tennant from Azure Systems. I don't know if you heard about him. He's a really nice guy. And this data structure is like a way of having a histogram where you can put data, but it does with a configurable precision system. So if you store 100 milliseconds there, it is not actually storing 100 milliseconds. It will correct the value, and the precision is configurable. So by default, we have 1%. So every measurement we take, we store it there, and it won't be more than 1% away from the value you actually stored. And it does that in a single data structure. Is basically a big long array that is in memory, but it's only allocated when you start your app. And so see, if I start an actor, then there is an histogram for storing things about it. It gets allocated only once. And there are no allocations when you actually do the recordings. And also the recordings itself are very cheap because it's just about doing a couple bit shifts to get the index you need to put the data on and do +1 on that index on the context array. So it's very, very fast to do measurements with this thing. So now that we have this thing, we instrumented the Akka bytecode by using AspectJ. We're doing that with Scala, so all the aspect code is in Scala is there in GitHub. We are measuring trace metrics, so traces for us is like if you have a request coming to your application, you do a lot of stuff to process that, and then you reply back to the user. The time taking for the application to do that, that's what we call a trace metric. We have segments, which are like little pieces of your trace, maybe a database call, an HTTP request to another service, and so on. We have actor metrics, so processing time, mailbox size, and timing of mailboxes, all kept in a HDR histogram, so you get all the values. Also, we have error counters, we have dispatcher metrics, and we also have a new system metrics model, which is still experimental, but we also can give you system metrics information. Also, we have user metrics because, well, we did all the work to make this store a lot of data, so I guess you guys may want to use that for your own things. So even if you're not using Akka, or you're not using Spray, and so, you can ask Kamon for a histogram counter, min-max counter, which is a thing we use to monitor queues or gauge, and then all that information can get flushed to the same metric backends we already support in Kamon, even if you are not using Akka or Spray. So we also have a Spray and Play integration. It means that that little piece of code that I showed you that tells you, hey, here's where a trace starts and here's where it ends. You don't have to do that if you're using a Spray or Play, because we already know where Play starts something and when it finishes. So we have instrumentation for that. We have segments, so if you do a client HTTP call using the Spray client or the WS client in Play, we already record the timings for that. And also we have automatic trace token propagation, which means that if you have a trace token in one machine, and that machine makes an HTTP request to another service, we are putting a header there with the trace token, so when it gets to the other servers, it will use the same trace token. So basically you have a universal ID that can go across all your nodes, and you have a way to, for example, if you're logging that, you can correlate all the logs for a single transaction across all your servers. And that's really helpful when you're doing this kind of applications. We currently have models for StatsD, Datadog, New Relic. We have a log reporter, and we're currently working on a InfluxDB module to report there. If you guys want to get your data anywhere else, you can just tell Kamon, hey, send the actor metrics to this actor over here, and it will periodically flush the metrics to that guy too. And in our roadmap, we have, well, the next version, which will come out sometime in the near future, like 2 or 3 weeks from now. We are planning to stabilize what we currently have and make it more user-friendly, have a better integration with New Relic, with Datadog, like make the things we already have a bit better. Then the next release, we're going to have cluster and remoting support. Some of our users are already using Akka cluster or remoting, so we want to make that work too. And then it is not clear when are we going to do this, but we have plans of first create our own metrics dashboard. It turns out that we have a lot of information, a lot of very valuable information, but most of the backends either downsample the information or are not able to show the kind of graphs that we would like to show about these things. So we want to do our own thing and let people enjoy about that. We want to create a new JHiccup module. I don't know if you heard about JHiccup, but it's quite interesting that it can help you detect how hard the garbage collection and other things that pauses your system are affecting your app. Then do proper event flow tracing, like you can get a Gantt chart, something like Zipkin does, but with Akka actors and features and asynchronous operations across your app, and support other non-reactive stuff. I think the first thing we're going to do is Scala, which is being used by some of our users, but that's it so far. So that's all I have for now. If you want to get started with Kamon, please go to our site. There is a simple guide. I know we have a lot of documentation, but we still need to do a lot more. So if you go there looking for something and you cannot find it, please let us know. and we will happily help you. There's a link for the mailing list and the Twitter account, so please reach out and we will help very gladly. So are there any questions? Yeah.
Is there any plan to support
Elasticsearch as the backend? We don't have any plans, but I guess it is absolutely possible. As I told you, you just need to subscribe the actors and send the metrics there. So yeah, it's possible. We don't have any plans to do that. Yeah.
How do you compare this to the Scala API for the this thin layer?
Yeah. Well, the CodeHel metrics has, I guess the only thing that is worth comparing is the histogram itself. And the CodeHel library, it has, I think it's reservoirs, the thing that has to store the things. And one of those keeps all the data, but it basically has an unbounded list of longs. So you can go out of memory by using that. The other one is a exponentially decaying reservoir that throws data away. It makes the assumption that the distribution of what you're storing there is normal, and based on that, it will throw away some data because it thinks that it will fit a normal distribution. And if you have been measuring latency, you will know that latency is nowhere near a normal distribution. And I think there's another one that I can't remember now, but basically with the high dynamic range histogram, we store all the data points we have, all of them, and you have it available so you can report it anywhere you want. Yeah?
So if a request is an async request which is flowing through 4 different actors, does trace context help us like trace down all the way to all of the 4 different actors?
Can you please repeat the question a bit louder?
Yeah. So let's say I have one asynchronous request flowing and it is moving through 4 different actors. Mm-hmm. Does trace context measure all 4 of them and give me the total time it took?
Yeah, of course. In that case, you will get 2 things. You get the actor metrics itself. So the actor, you know how long does it take to process messages in the actor. And if you say, well, my trace starts here and finishes 4 actors away, then it will measure how long did it take from this point to that point. Okay? That's essentially what happens with Spray. There is a bunch of events that go from the server connection all the way down to the response. And you can also do that manually. Actually, one of our apps is like a crawler, and we don't have external requests, but we are generating load. And we do have some manual, like a manual setting for saying, here is where it starts, here is where it ends, and Kamon will measure that for you.
So I haven't looked at the InfluxDB. What makes it a good backend for storing data? And out of the various backends you have, which one do you recommend? Which ones work best in practice?
I cannot give a strong opinion about InfluxDB because I just started reading about it. It seems really interesting, but we'll still need to explore that further. From the ones we have, I guess StatsD it's going to be the default way to go, because even while it downsamples some data, you can tweak StatsD to get more data out of it. And actually, we have a Docker image. If you go to the site and the team blog, there is a post where we published a Docker image that has StatsD, Grafana, and Graphite, so you can just start that, because installing that is really painful. You can just start that, start your application with Kamon, and tell it to send the data there, and you will see dashboard with actor metrics and trace metrics and so on. Any other question? There was one around here.
I was curious if you had any plans to have OpenTSDB as a backend?
No. Actually, a guy asked that a few days ago. We don't, but I think there is a bridge between StatsD and OpenTSDB that you could use to get the data there. Any other question? OK. Good. Bye. Thanks.